Here is a matching type question on general organic chemistry. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us now begin solving this step by step. We need to rank each group from strongest acid, 1, to weakest acid, 4. Part A. Carboxylic acids with halogen substituents. Key concept: electron-withdrawing halogens stabilize the carboxylate anion, increasing acidity. The closer the halogen to the carboxyl group and the more halogens present, the stronger the acid. CH3CCl to CO2H to Cl atoms on the alpha carbon, strongest inductive withdrawal rank 1. CH3CH to HBr-CO2H, 1Br on alpha carbon, strong inductive withdrawal rank 2. ClCH to CH to CH to CO2H, 1Cl on gamma carbon, weak inductive effect, 3 carbons away, rank 3. CH3CH to CH to CO2H, no halogen, weakest acid rank 4. Order 4, 2, 3, 1. Part B. Oxygen acids of different types. Key concept: carboxylic acids, phenols, benzyl alcohols, ethers are not acidic in the typical sense. C6H5CO2H, benzoic acid, carboxylic acid, pK-4. To strongest rank 1. C6H5O, phenol, pK-10 rank 2. C6H5CH2O, benzyl alcohol, pK-15 rank 3. C6H5OCH3, anisole ether, essentially no acidic proton, pK-15 weakest rank 4. Order 3, 1, 4, 2. Part C. Mixed oxygen containing compounds. Key concept: carboxylic acids are stronger than alcohols, ketones and ethers have very high pKa values, alpha CH of ketone -20, ether OH absent. Cyclopentane carboxylic acid, carboxylic acid, pK-4.9 strongest rank 1. Cyclohexanol, alcohol, pK-16 rank 2. The ketone, dietert-butyl ketone type, 3,3-dimethyl-2-butanone or similar, alpha CH, pK-20 rank 3, 1, 4-dioxane, ether with no acidic proton, pKa 35, weakest rank 4. Order 2, 1, 3, 4. Part D. Nitrogen bases ranked by acidity, conjugate acid strength or NH acidity. Key concept: here acidity refers to NH acidity or the acidity of the conjugate acid. Amides, lactams, are far less basic than amines because the lone pair is delocalized into C is equal to O, making the NH more acidic. Among amines, electron-donating groups increase basicity, decrease acidity, while resonance withdrawal decreases basicity, increases NH acidity. Aniline's lone pair is delocalized into the ring, making it least basic among amines, most acidic NH among the amine group. N-methylpyrrolidine has no NH, so it cannot act as a proton donor. 2-piperidinone, lactam, NH adjacent to C is equal to O, lone pair delocalized, NH most acidic rank 1. Aniline, ARNH to resonance delocalization into ring makes NH more acidic than aliphatic amines rank 2. Piperidine, aliphatic secondary amine, NH pKa of conjugate acid -11, NH pKa -35 rank 3. N-methylpyrrolidine, tertiary amine, no NH, cannot donate a proton, weakest acid rank 4. Order 2, 3, 4, 1. Therefore, the correct answer is A, 4, 2, 3, 1, B, 3, 1, 4, 2, C, 2, 1, 3, 4, D, 2, 3, 4, 1. The answer is shown on screen.